Over the past few days, a new open-source image model has been getting a lot of attention. It's called Ernie image, and it's being positioned alongside some of the strongest open-source models available today, even compared to Nano Banana 2. At first glance, that sounds promising. But there's an interesting limitation. It focuses purely on image generation, without image editing capabilities. So the real question becomes, how good is it at what it's designed to do? In this video, I'll walk you through a full set of tests from image quality and style control to more complex and edge case scenarios, and by the end, you'll have a clear idea of whether it's worth your time and resources. Hello, welcome to Smart Vision. On this channel, I keep sharing the latest AI tutorials and practical tools. All workflows, materials, and resources from this video are on my Patreon and are available to download after you register. For supporters, I provide extra professional tools and deeper guides. If you like this content, consider subscribing and supporting the channel. Now let's get started. So, what exactly is Ernie image? It's a text-to-image model released by Baidu, built on a relatively new architecture called Diffusion Transformer, or DIT. In simple terms, this isn't just a model that draws pictures. It's more like a model that understands what you're saying and then draws based on that understanding. So what is it really trying to do? The official goal is actually very clear. Ernie image isn't just trying to make better-looking images. It's trying to make the model more controllable and more obedient. Because most image models today have a common problem. They look good, but they often misunderstand your intent. For example, when you ask for multiple objects, specific positions, or complex relationships, many models start to break. And this is exactly where Ernie image focuses. Its first core capability is strong instruction understanding. You can give it complex prompts like a red cup on a blue table with a cat next to it. These kinds of multi-object, multi-attribute, spatial prompts that are much less likely to break. The second standout feature is text rendering. It can actually generate readable text inside images. And unlike many models that produce gibberish, Ernie image is specifically optimized for this, which makes it useful for posters, UI designs, infographics, and even comic dialogue. The third capability often overlooked is structure generation. It's not just about single images. It performs better when dealing with structured content like storyboards, comics, multi-panel layouts. This makes it particularly suitable for content creation workflows. Now let's talk about scale. Ernie image is around 8B parameters, but the goal is to achieve performance close to much larger models. In other words, it's aiming for strong efficiency. If you have a graphics card with 8 GB of VRAM, you can definitely run it locally. There's also an accelerated version called Ernie Image Turbo. It runs much faster, but with slightly reduced detail. So to summarize, Ernie image is trying to solve a very specific problem. AI can generate images, but it doesn't always understand what you mean. Its direction is clear. Not just generating images, but generating them correctly based on your intent. They also provide benchmark scores, and based on those numbers, it ranks as one of the strongest open-source models. But the real question is it actually that good? Let's find out through real testing. As usual, let's quickly go over the installation. If you've seen this part too many times, feel free to skip ahead. First, install comfyui. If you have an NVIDIA GPU, search for comfyui on Google, open the site, and download the appropriate version. If you have an AMD GPU, download the AMD portable version of comfyui from the comfyui GitHub page. After downloading, extract it, and it will be ready to use. I'm only giving a brief demonstration here because I don't have an AMD GPU and haven't tested it myself. Also note that some comfyui custom nodes may not support AMD GPUs, so keep that in mind. Next, download the model. You can open the official workflow provided in comfyui. Once opened, you'll see an error in the top right corner. Click See Errors, and it will show you which models are missing. Just download them. One important note, you don't have to use the official SafeTensor models. Instead, you can use the nearly lossless Q8 GGUF versions. You can find both Ernie image and its turbo version on Hugging Face. Go to the Files section and choose the Q8 model. It only requires about 8.69 GB of VRAM, which is nearly half the size of the official model, with almost no quality loss. If your GPU has less VRAM, you can choose lower precision versions, but quality will decrease accordingly. After downloading, you can load the model using the UNet Loader GGUF node. Make sure to update the nodes provided by City96. If you don't have the node, go to Extensions and search for UNet Loader. There are two workflows, Ernie Image and Ernie Image Turbo. Let's start with the standard version. By default, the workflow looks simple, but you can unpack it to see more details. It has two main modules, prompt enhancement and text-to-image generation. You just need to input the image size and your prompt. There's also a toggle to enable or disable prompt enhancement. The rest is a standard pipeline. Model loading, prompt input, image size, K-sampler, and output. Nothing unusual here. The only thing worth noting is the sampling steps. By default, it's set to 20, but the official recommendation is to try 50 steps for better quality. The turbo workflow is almost identical, except negative prompt is replaced with conditioning 0 out, and K-sampler uses only 8 steps with CFG set to 1, optimized for maximum speed. Alright, now that we understand the model, let's move on to real testing. During testing, I will use the Ernie image model directly instead of the turbo version to achieve the best results. For the steps, I'll keep them consistent at 20. We'll start with the basics. Style control. A good model should clearly distinguish between styles. We'll test realistic portraits, anime style, and then a more challenging combination, a sci-fi robot in ink painting style. Here we're checking for style consistency. If it fails here, there's no point going further. From the results, style generation is completely solid. Even when combining two conflicting styles, it still matches the prompt quite well. Take the sci-fi robot plus ink painting style for example. It actually feels pretty natural, no real awkwardness there. Of course, this kind of mixed style isn't super practical, but it's a good way to test how the model interprets ideas. And sometimes, my own prompts might be the problem. So yeah, my bad. Next is composition. We test a multi-person scene, 6 people around a table. We only care about 2 things. Are the numbers correct? And is the layout stable? Wow, there are indeed 6 people at the table. But something feels a bit off. Let's play a quick game. What looks unnatural here? I'll give you 3 seconds. 3, 2, 1. Alright. First, 3 of the guys look almost identical, like triplets. Second, the food on the table looks a bit unnatural. And the guy on the right, his left hand is slightly distorted. To be fair, this is a pretty complex scene. But in terms of composition, it does follow the prompt correctly. So structurally it's fine, just needs improvement in the details. Now comes the most important part. Instruction following. We test a classic prompt. A blue ball inside a red box, on a green table. They mix up colors or spatial relationships. So this test really answers one question. Does it actually follow instructions? Alright, this one works exactly as expected. The output matches the prompt perfectly, nothing much to complain about. If I had to nitpick, it kind of cheated by turning the green table into the background. Then we increase complexity. Multiple characters, multiple attributes. From here, you can judge how stable its understanding really is. So far, it's looking pretty stable. Everything matches the prompt really well. Still haven't found a clear weakness yet. Let's keep going. Next is a key differentiator. Text rendering. We generate a poster with a title. Here we check spelling, readability, and layout. Because most models fail badly here. If it works, this is a big advantage. Here I tested 2 types of prompts. One in a single language, and one mixed with multiple languages. And honestly, this is kind of impressive. It follows the prompt almost perfectly. There's really nothing obvious to criticize here. So yeah, in this area, it definitely lives up to the claims. Then we test structured generation, like a 4-panel comic. We expect clear panel separation, consistent characters, and logical flow. Oh my god, this actually looks really good. Except that fish looks a bit weird. If it could support character reference inputs, this would be perfect. A bit of a shame. Now we push it further. We test tricky prompts. For example, a cat looking into a mirror, but the reflection is a dog. This tests logical consistency. Alright, this one also matches the prompt perfectly. But now I'm curious. What happens if I don't specify that the reflection is a dog? Let's try that. Okay, interesting. The mirror still shows a cat, but the face direction is wrong. So logically, it's still a bit off. Then a stress test. 10 different objects in one image. We check for missing elements or chaos. At this point, the model's real limits start to show. Alright, again, this matches the prompt very well. Its understanding of text and instructions is actually quite strong. Finally, extreme cases. Multiple people with different attributes. Very easy to fail. And an information-dense AI poster, which requires structure, layout, and clarity. Same here, no major issues. Except, everyone still looks kind of similar. At this point, we can give a clear conclusion. The key strength of Ernie image is not just how good it looks, but how well it understands your intent. So now we can answer the real question. Is it actually worth using? So overall, if you're generating posters, this model is actually very well suited for that. But for human characters, personally I think it's just average. The faces aren't especially appealing, and in multi-person scenes, they tend to look too similar. So in my opinion, it's better suited for posters or commercial-style image generation. If that's what you're looking for, don't hesitate. Just go ahead and download it. Alright, that's it for this video. If you enjoyed it, don't forget to like and subscribe. Your support is what keeps me going. All the resources used in this video will be shared on my Patreon. You can access them by joining for free. See you in the next one.